welcome to my talk about Laravel design patterns. I hope everyone can see the screen. If not, move around or get closer or whatever. Yeah, just do that. So let me first introduce myself. I'm Bowman. You can find me on Twitter. I work at Enrise as a developer. No full stack developer, just developer. I'm the creator of Markdown Mail. It's something Laravel related. And I'm also very active on Laracast. I'm one of the top contributors on Laracast, which I help people out. I'm enjoying helping other people's fixing their problems. And in this case, it's mostly Laravel related, but it's in general mostly PHP stuff. And actually today I reached the 1 million points, so I'm really happy about it. I'm still the second one on points, but I'm the first on most best replies. So I'm happy about it as well. I'm above 1200 now, so that's really cool. Yeah, well, that's me. Let's talk design patterns. So we will dive into a small explanation on how design patterns work. While we're doing that, we're going to do some sample code in just regular PHP, and then we look into how Laravel is doing that. I learned most of this stuff during my college time. We were doing Java, PHP, C++, but the design patterns were always the same. We were always doing the same kind of constructs, it's only a different language. And in my daily job, I try to apply these design patterns to make most out of the code and the code base, and to also make it maintainable and readable for my colleagues. So, daily design patterns. Most of us use them every day without realizing it. It makes your code cleaner, it looks good, it feels right to use them. You might not have a name for it, but you're using them anyway. So when writing software, we create classes, interfaces, we do that all the time. And using classes and interfaces, we're already using these design patterns. Now the question remains, what design patterns are we actually using? So let's look at what design patterns are. Design patterns are common occurring problems. And it's not something that you can copy and paste. It's different every time. And they're building blocks that describe how a problem can be solved. So I like to describe design patterns as recipes. I hope you're not getting hungry because there's a lot of food pictures here. So there's small food afterwards. So design patterns are not really a blueprint. It's not a set of defined requirements. And in the end, you're the chef of your own project. So you can use that recipe of the design pattern in your own code base to create your own dish or project. So we're going to be chefs today. And I want to say be your own chef. So for me, design patterns are about understanding the recipe of the design patterns, and how you use them is up to you. So you might want to add some Behavioural pepper to make it work for your project. You're free to do so. And use your own imagination. Design patterns are not strict to some requirements, but you need to stay in the boundaries of the design patterns. We're going to see more examples of that. So why use design patterns? When using design patterns, the goal is to build maintainable code. You want to improve readability, coupling, and consistency in your application, and that all contributes to maintainability. So when we build an application, we want the code to look beautiful and structured, but we also want, to be maintainable, so we can reuse it. Others can easily implement stuff on it, and design patterns can help us achieve that. In the end, it's all about understanding the technical language about the design patterns. So there's no silver bullet in doing this. There's no golden way on how to achieve this. Each application is different, and so are the needs for the design pattern. So keep that in mind. What you see today might not be useful for your project, although it might seem that way. It's probably not. Every project is different. So I mentioned maintainable code a few times. Let's dive into that a bit. Maintainable code means that it's easy to modify or extend the code for a developer. At the heart of maintainability is carefully structured code. And that code needs to be easy to read, easy to find, easy to search. code that is easy to dissect in order to find a particular component. And code that is easy to modify without the risk of breaking another feature in your application. That's also one important thing about maintainability, that if you move something or adjust something somewhere, that the rest of the code doesn't just fall out. So that's one of the most important things. So the following 5 subjects combine the full definition of maintainability for a developer, in my opinion. So the code should be easy to read, it should be adaptable, so you should easily be able to add a new feature without having to refactor a lot of stuff. And finally, debuggable code also helps finding mistakes easily. You can easily make tests for it as well. If it's debuggable, you can easily go through it and see what's going on. So that's really important. Principles like try, so don't repeat yourself, and KISS, keep it simple, stupid, also help to keeping your code maintainable. So writing maintainable code is not hard. You only have to think about it. You have to carefully think about it. You have to think before you build something. And that makes it easier to make maintainable code. So time for design patterns. So design patterns can help us build maintainable code. So let's dive into some design pattern types. There are different types. And these are the 3 most common types in PHP in general. So let's dive into each of these types. So we split them in 3 different main types. Creational patterns. They're all about creating objects. So they're hiding the logic to create an object. So you don't really care how the object is created as long as you get that object back. There can be a lot of different calls or methods behind that, but you don't care. You just want to call one method and get an object back. Creational patterns solve the problem of complex initiation of objects. So you're going to put it behind a class. We're going to see a lot of examples of this. Structural patterns describe how inheritance works between objects. So it's all about realizing the relationship between these objects. Structural patterns solve the problem of complex composition between objects. And we're going to see, it's mostly interfaces, that helps a lot, or abstract classes. We're going to see more about that. Behavioral patterns, that's all about communication between the objects. They increase flexibility between the communication of those objects. And it solves the problem of complex communication between objects. So who has never used Laravel before? There's one guy? Okay. So there might be some code examples that you might not understand because it's Laravel related. We're going to do a PHP example first and then a Laravel example. If you have any questions afterwards, just let me know and we can dive into the code. So these are one of the patterns, or one of the most common patterns that are used in Laravel. There are much more design patterns, but it just didn't fit on the slide. So these are the most known patterns as well. Probably everybody has heard about the factory pattern. That's one we're going to dive into as well. We don't have time for all of them, so we're going to do these 4. We'll see how far we get. If you have any questions afterwards, you know where to find me. So the factory pattern. I first want to do an abstract example, so we're first going to see how this works. We're going to do a lot of things with pizza today. So I hope you're not getting too hungry, otherwise I'm going to ask you guys to order pizzas, so good to know. So let's say you want to make a pizza. For a pizza we need a few things, and one of that is ingredients. Think about cheese, tomatoes, dough. We need a lot of things to create a pizza. So let's take the cheese example. So when we want to create cheese, we first need milk from a cow, and we need to collect that from the cow. After milking the cow, we need to process the milk, and we need to heat it, we need to cool it down, and we need to shape it. And after that, we need to put it on a rack for a few weeks, and then afterwards it's eatable cheese, and we can call it officially cheese. But instead of waiting for weeks, we just simply go to the supermarket and we buy a bit of cheese. So in this case, the request to the supermarket for cheese is the factory pattern. We're actually asking the supermarket, give me cheese, and it doesn't really matter how they get the cheese, they just give it back to us. And same goes for all the other ingredients. So, like tomatoes, we don't really care where they come from, as long as we get our tomatoes. So, this is a creational pattern. You probably guessed it already. So, this is responsible for initiating objects. And it solves the problem of creating complex objects throughout your code base. And this makes it maintainable and reusable as well, because you have one place where you can create that object, and you can call it on many places. And you can easily test it as well, because you can just ask that object. So it decouples code in the way that sometimes a factory or an object can have a lot of parameters in the constructor. And sometimes there's a lot of default parameters, so you can put it behind a factory, so you don't have to pass in all the values all the time. Everything regarding creation or initialization is contained in a single class or single method behind everything, so you don't actually have to care what's behind that, you just want an object. So if we look at an example here, where the pizza factory is responsible for making a pizza. So we're using PHP 7 here, so using actual return types. But we create a new pizza. We don't care how the pizza is created, as long as it's created. In this case, we have an interface for the pizza factory, and it just has one method, so we always make sure that the factory is making the correct pizza for us and doing the correct calls. In this case, the pizza factory always creates the same object. So wherever you call it, you always get a new pizza object with the same content. It's always the same kind of object. So Laravel is actually using this pattern for views, but also for notification, validators, and there's a bunch more, but these are the most known. In this case, we use a helper method, and that's the view method. And in the end, the view method is calling a factory, which is creating the view for us and returns it to us. But in this controller method, we're actually returning the view. So in this case, we give it a name, post.index, and then we give it some data that needs to be parsed to the view. So if we dive into this helper method, we can see that we first create a factory, a view factory. And then we call the make method on it. So we already have a factory, just like the pizza factory. And we call make on it, just like on the pizza factory. And we give it some data, and it's just going to return us a view instance. The factory is in this case also behind the helper method, so it's even cleaner than normally. But if you're in your normal application and you want to use factory, this is the way to go. So we now have one single place that is responsible for creating the view, which can be reused. We can reuse this helper method everywhere. Or we can reuse this factory make call everywhere where we want, and we always get a view object back. I hope everyone can read this. It's a bit small. If we zoom in into the make method, we can see it's doing a lot of logic. So Laravel is doing more things because it's a framework, so it has to handle more ways of handling code. But in the end, a view instance is returned. We always, as you can see here, we always do return new view. And then it will always return that object. And that is the way of how a factory works. We always want an object back. We don't care how it's created. So we're going to use that view helper method every time. We don't care what's going on behind that. We just give it a view name and some data, and we get that view object back always. So another example is the validator. And it's actually doing the same thing. It might look a bit complicated. But in the end, it's still creating a new object. So it's creating here the return new validator object. So it's creating a new validator object. And we have that in the form in Laravel as the validate helper method. Or on the request class, you can call validate. And it's actually creating that validator object with the data you give it. So the logic is more complex, but the pattern is still the same. So this is getting more complex, and we want to be more extendable with this, and that's where the next pattern comes in, and that's the builder pattern. So we're going to stay with the pizza examples, and we're going to build a pizza. So we already know how to make ingredients using the factory, and now we're having a design pattern that can work with factories. So let's example the pizza using the builder pattern. So a pizza has the same setup every time. It needs to be, the ingredients need to be put together, it needs to be baked, and so on. However, each pizza is different. There might be different cooking times, there might be different ingredients. You can even create your own recipe for your pizza. So it's a wide scale of pizzas. So for that, we can create a different builder for each pizza recipe. Also, we need different amounts and ingredients. So we need more and more complex initiation. We need more options for our builder. So we're going to make a builder for each one. So in this case, for example, the pizza baker is using different builders to create different pizzas. The pizza baker is the builder in this case, and it uses the builders to create the pizzas. So in the end, the pizza baker provides us with a pizza. So let's dive in a more technical explanation. This is also a creational pattern. We're still initiating objects. And it's more responsible for building complex objects. And it can use factories to actually build these objects. And it's also called the manager pattern. The manager class is referenced in Laravel a bit more, but it's still the builder pattern, or somebody also decided to call it manager pattern. It's fine, both are the same. So it's focused on building complex objects step by step. It always returns an object. That's one of the important keys of this design pattern. It always returns something. Where the factory pattern would return one object at a time, and right away, it will always return that object. That's where the builder pattern can make decisions on what to return. So it has multiple ways of returning something. It can return different classes. So it has much more functionality. So let's dive in the builder example. We first need to think out how our builder will work. Every builder object should adhere to some interface. In this case, the pizza builder interface. So we have one simple method make. In this case, it will always return a pizza. So we're calling the make method for some kind of pizza. And in this interface, we're trying to show how this should work. So our make method in our builder should call these three methods, and that's it. So every pizza builder should adhere to this interface. So every pizza builder should have a prepare, apply toppings, and a bake method to prepare the full pizza. Now, if we look at an interface, it's relatively easily. It has these three methods, and it always returns pizza. Now, let's build an example pizza builder. It might not be clear yet, but we're going to work to an example where it will be clear. So the builder is responsible for creating the pizza object and implementing the pizza builder interface. So this is the blueprint of each pizza object. And our pizza object builder understands this margarita builder. So we're making a margarita pizza. And because it has the pizza builder interface, we can now use the builder to build this pizza. So if we look at that, we see the interface above here, where it's applied. And when we call a new pizza builder, and we call a make method on it, we can just pass it a new builder, and it will actually make that pizza for us, because it has those methods. It knows how to build that pizza. So in this case, we always get a pizza object back, but it has the properties of a margarita pizza. So each pizza is different, but in the end, they still have the same build steps. So if we look at another example, for example, the chicken builder. So we're going to make a chicken pizza. In this case, the toppings are different from the margarita, but it's still a pizza object. It's still the same kind of object. And since it's using the same interface, it's still returning a pizza instance. So the pizza builder can understand this chicken builder object just like the margarita builder object. Because they both implement the same interface, they are both interchangeable, so we can call make on the pizza builder with both of these objects, and we always get a pizza back just with different properties. One question?
Is this a small mistake that you should return pizza make, or do you return the builder?
No, in this case, the pizza is fine, because make is returning the pizza itself.
But you're returning pizza, which means that you're returning the pizza builder, because pizza is a variable. It's a pizza builder, not pizza.
Yeah, it's of the interface pizza builder, but in the end it's a pizza. The pizza builder interface is the one that decides how the pizza should be built. So the pizza builder in this case, for example, this chicken builder, it's always giving a pizza. So it's a pizza object, but it's implementing the pizza builder interface.
Yeah, but in here you create a pizza object.
So we're returning.
And you return
Ah, check.
object.
I know what you mean. It's not the pizza object. Yeah, honest mistake. I will fix it up. Thank you.
This is called bake in your chicken line.
What again?
It's called bake, yeah.
Ah, yeah. It should be make. Yeah. Fair enough. Honest mistake again. Okay. So in this case, it's easy to make new builders. We can now create a new builder because we have the interface. So we just have to implement the interface and we have new pizzas. So this pattern aims to build simple and reusable objects. And it separates bigger objects from the rest in its own separated layer. We can create an own namespace for this, for example. And that means it's outside of the layers of your application. So you can also put it in a package, for example, and reuse it on different projects. We're going to come back on that later. So Laravel is using this pattern a bit differently, but it's still the same pattern. It's only more advanced. It's still the same pattern. Laravel uses an abstract manager class that defines how a builder should work, and it's used throughout the whole code base. So let me first do the pizza example, and then we're going to dive into the Laravel example. So for each pizza builder, we have a separated driver method, and that's how Laravel builds the driver method. And each driver should return some class that is extending some interface or abstract class. So in this case, the pizza manager is responsible for calling the correct driver method. The implementation for this is done in the abstract manager class. We're extending the manager class. So these methods might not seem logical right now, but we're diving into that. So when we call the driver method on the manager class, it's going to look through the drivers which it has enabled, so available. So if we give it the string margarita, it's going to create the string create margarita driver, and it's going to call that method and return that object. So in this way, it's really advanced on how to manage dependencies and objects that it's going to return. So let's look at the create driver method. This is what I'm talking about. It's going to call create a method string create your driver name and then the driver string, and together it's going to call that method and return that. I won't go too deep into this, but this is how it works. So we create the method based on the driver name. So for example, in this case, we're going to call margarita on it. So we have a manager, and we call driver on it. And if we give the string margarita, it will turn the margarita builder for us. So in this case, we have a margarita builder we can build pizzas with or whatever. Laravel is actually using this technique on multiple places. And one of the most obvious places is the email that they're sending. So this is the transport manager class. It's used for sending emails. So based on this driver name, the correct transport class is returned. All classes extend the abstract class called transport in this case. And the pizza example, we used an interface, but an abstract class is fine as well. And when we look into this, the transport manager also has a get default driver, and is always fetching it from the config. So if you in your config change your driver from SMTP to log or something, it's going to call the log driver instead of the SMTP driver. So this way, Laravel is really flexible in how to handle these dependencies. In our pizza manager case, we used the default string margarita. And in all the other cases where Laravel is using this, for example, the cache and so on, the default is mostly generated from the config. So when we look into this, in your env you can set the mail driver or you can put it in your config. In this case, by default is SMTP. So we always call a driver method on it. Then we're sending the email using the Facade, for example. It's going to call this method. And then we get the create SMTP driver. It's going to give us an SMTP transport class back. And because it's extending the transport class, we can just call send on it and it will send the email for us using that config. And so we can, for example, in our controller, we can call mail to and send an email. And we're not saying anything to the mail send method on what way it should use. It's already configured. So Laravel is smart enough to actually configure this for you. So every time you want to send an email, it's going to call that transport manager and ask, give me the correct current driver, or give me the default driver. The cool thing about this is that we can change this during runtime, because you can, for example, send an email via SMTP and then set the config. You can, for example, set the config to log, and then when you call mail again, it will use the log driver because that's the current config. And Laravel will call the get default driver again, and then it's going to use the log driver, so the log transport class, to actually send the email, and it will end up in your log. So this way we can use multiple drivers in one call. Not really sure if it's recommended, but you can do it. So Laravel is actually doing this on a lot of places. For example, the auth manager, the cache manager, the session manager. So these are the namespaces. So if you just put this in your RD, you can find them. Use it for your own inspiration. So you can get a lot of cool stuff out of it. So the strategy pattern. We now know how to make objects using the factory. We also know how to build pizzas. And we can actually build multiple pizzas with builders. However, creating pizzas is not enough. We also need to deliver the pizzas. We're going to look in deliveries. So delivering pizzas can be done in multiple ways. For example, with a scooter. That's the most common one. With a drone. It's 2018, so we can actually do this now. So that's cool. Or by bike. I'm from the Netherlands, so we do this by bike. I'm not sure how it is in Belgium. Are they doing it by bike?
Sometimes for bike and sometimes motorbike.
Electric bike, right?
We do drones.
Yeah, okay. See, that's much better. So in this case, the strategy doesn't really matter as long as the pizza is delivered. We can say that all delivery ways serve the same purpose. Delivering the pizza on time, on the correct location. That's what we want to achieve. So this is a behavioral pattern, and it delegates to the different algorithms it provides. So it has multiple algorithms to actually do something. And it's all about defining a family of algorithms that are interchangeable. And we will look at the code example, and then you understand the interchangeable part. And it's mostly using an interface. So the implementation is in different classes. We can put it in different classes because they all use that same interface. There's actually like a God thing where you can say that every interface is a strategy. I'm not going into that, but you can think about it. It's for a good night's sleep. So the strategy pattern is a perfect example of the open and close principle. Interface is easy to extend or implement, and it's closed for modification because it's an interface. You can just change an interface and the rest will break. The implementation needs to adhere to the contract of that interface. So let's look at an example. We first need to define an interface with the signature of the algorithm. In this case, it's just deliver with an address. So let's say we're going to deliver with multiple strategies. So each strategy needs to have that deliver method that accepts an address object. Each strategy is responsible for implementing the delivery strategy, and we don't care how they do it as long as they do the delivery. So for example, the bike delivery is using a bike route to determine the cost and delivery time, for example. This way we can deliver it and we know how long it took. We don't really care how it happens. It doesn't really matter what kind of code it does, as long as it's delivering something. So, for example, we create a pizza delivery, and we can just say the pizza delivery, deliver something to an address, and we don't really care what kind of object you use, what strategy you use. It can be any strategy. In this case, we choose for the bike strategy. So we give it a strategy and an address, and it will do that for us. So our pizza delivery class is responsible for actually calling the delivery method on it. Because the delivery strategy interface is in the pizza delivery class, we can actually add new strategies and we can replace them. So for example, the drone strategy it's doing the same thing. It's implementing the same interface, it's doing its drone route, calculating the cost, and so on. So now we have two methods. And this looks like the builder pattern, but they're completely interchangeable right now. We can call deliver and pass in the drone delivery. Doesn't really matter which one we do as long as the pizza is delivered. And each strategy is encapsulated in its own class. So we can easily test it, we can easily modify it because it's in its own class, and we can easily add new implementations. So that's the power of the strategy pattern. So you see a lot of these things also coming back in other patterns. With the builder pattern, you can almost say that each pizza builder is interchangeable as well. So Laravel is actually using this in quite some places. Not in the way we just showed in the example, but more in interchangeable ways. Some are more advanced than others. And most of the time Laravel has only one implementation of it. So let's first dive into a simple implementation. For example, the encryptor in Laravel. It has a simple encrypt and decrypt method. And this interface has two methods, encrypt and decrypt. It's not that hard. So when we look into that implementation, it's doing all kinds of things. It's creating a class, it's setting some values, and then it's calling the encrypt method. You don't want to see the encrypt methods, they're pretty complicated. So if you really want to see it, dive into the code. This is the namespace you can find it in. So Laravel is using the advanced encryption standard. So it's good encryption, so it's really cool to look into it. However, we're awesome developers, so we can build our own implementations. So we can easily build our own implementation using something different. For example, MD5 in combination with all different kind of other things. Don't look at the code, it's just an encryption and decryption. But in the end, we just need to adhere to the interface. We just have an encrypt and a decrypt method, and they're returning a value. Other examples in Laravel are, for example, caching. And each caching interface is also interchangeable, because caching is a wide range of methods. You have a get method, you have a put method, and if you're doing that in an array or in a config file or on Redis, it doesn't really matter, these methods are still the same. So you can find more of these in these namespaces. Note that I pointed out to the interfaces, so if you use your IDE and click on the interface, you can find the usages. For most of them, there's only one implementation. For example, in Encryptor, there's only one implementation. For the hasher, there's only one implementation because Laravel is only using vcrypt. But for session, there are more implementations. For the store, there are more implementations. For the loader, there's only one implementation. So yeah, use that for inspiration. It's really cool how it's set up. Laravel is putting all these strategies or interfaces in its own contract directory, in its own namespace. So they're all grouped together, so you can easily look through it. I think it's an idea from Taylor, but I'm not really sure what's the thought about it. So we're going to dive into the provider pattern. This is the final pattern. And this is the final step for our pizzas. Does somebody know what the next step can be? Or what?
Eating?
No, it's not eating. Oh, very close, very close. So we can deliver them, we can assemble them. So let's look at a real example. We need some place to eat it. And that's what we call a franchise. So, for example, Domino's Pizza is a complete franchise chain. In this case, Domino's is the provider that provides us the way on how to build pizza. So they provide us the recipes and everything we need to set up a franchise. So they make sure that we have the correct ovens and the system, delivery systems. They're all provided by Domino's. So they provide us also with the pizza builders and the correct ingredients to actually build these pizzas. We only need to run the franchise with the given tool. So we only need to implement these classes to actually be a franchise. So the provider pattern is the perfect example of the tell, don't ask principle. The provider pattern makes it possible to extend your application with extra services. And it's like a plugin into your application. like packages in Laravel. Freek knows a lot about it. Around 180 times he knows about it. He has almost 180,000 public repositories.
180 public repositories.
It's a lot.
But it's teamwork.
It's teamwork, okay.
not only-
Spatie knows. So the key here is that it provides a service. It provides classes that you can use or reuse. So if we look at the provider pattern in Laravel, we're actually doing something with the IOC container. We're registering classes in the IOC container. We're going to tell Laravel that we're going to make some implementation available in the application. And this subject, service providers, can use their own talk. Their container of Laravel can use its own talk. So I'm not going to dive too deep into it. If you have more questions later on, just ask. I'm just going to do an simple example. So in this case, we bind the full path into the container. So we're going to make that pizza manager available in the container under the string pizza manager. So if we ask Laravel to create a class by the name pizza manager, it will return that pizza manager class for us, and then we can call the builder methods on it to build pizzas. So service providers are used throughout the system, throughout the framework, to register services. You can find them in your app.php file in your content directory, and you can add your own implementations there, for example, third-party packages. And you can find a lot of information about this in the documentation. It's really recommended to read that if you're going to play with Laravel. And otherwise, ask it on Laracasts, and it will probably help you out there. So now that we have registered this pizza manager class, we can actually resolve it from the container. We can use the app helper, for example, for that. It will create an application for us and call the pizza manager class and resolve that out of the container and return the pizza manager class. And then we can call different methods on it. We already used that manager example with the driver method, but we can do that here as well. And in your provider pattern, using the provider pattern, you can, in your container, register different kind of objects and configure them. You can even register multiple classes if you want. So the Laravel example is more focused on Laravel packages. So I won't be showing a full example this time. The package every Laravel project should have is probably the Laravel debug bar or the Spatie database backup package. So this is the perfect example for the provider pattern and its power as well. So we're registering the Laravel debug bar in the container under the string debug bar. Now we can just resolve from the container, but in this case it's just a service that's available. And since it's registered its own class, it also accepts the HTTP driver and so on. So it's configuring the object before it's going to be returned. So the provider pattern helps us extend the framework here. In this case, we can easily replace providers or add more packages to it. So if you want to, for example, don't want to use Eloquent and you want to use Doctrine, you can put in another package and remove Eloquent from it, and it just works. That's the power of the provider pattern. It provides us services, classes that we can reuse in our application. So if you have a class that you're always using in every project, put it in a service provider and you can reuse it in all your projects. And you might end up with a lot of packages, but that's a good thing. So a small recap of the factory pattern. A factory pattern can translate interface to an instance. It's used to setting up simple objects that don't need any other logics to be built. And we use it for setting up simple ingredients for our pizzas. And in Laravel, we use it for building up views. And it's a single place for creating the same object every time. The builder pattern can do the configuration for an instance without passing it to the instance. Makes it possible to create different drivers and after that to configure them. We use it to build the pizza manager who is responsible for creating the correct pizza object for, in this case, for us, the pizza builders. Strategy pattern provides us a class which can decide which algorithm or strategy should be used. Each strategy should adhere to that strategy interface, which makes them interchangeable. Each strategy is encapsulated in its own class, which makes them testable, reusable, and changeable. And we can easily add new strategies because we have an interface. We can easily create more of these strategies. Yeah, new delivery strategies, for example, like a ground drone or maybe something like Bitcoin pizzas or something. There's probably a way, as long as it adheres to the interface, it works. So the provider pattern lets you extend the framework by registering new service providers. Well, the whole Laravel framework is set up like this. You can find it in the app.php file. It's easy to replace and add new services. It makes it possible to reuse the same object or the same logic in multiple projects. And in our case, it was the franchise that we used to actually use the same pizza manager every time. So wrapping up, we've seen a lot of packages work together here. We should now actually order a pizza using something, right? You can order pizza. Can we order pizza? Is that a thing?
I don't know.
I'm paying, that's fine, but can we order pizza? Is there anybody into pizza?
You're paying?
I see some people, yeah, pizza, yeah. Okay, we're gonna order some pizza, it's fine. So, if we look at, for example, this pattern, we can see that we're using multiple patterns together now. We're using a service provider, so we're using the provider pattern. We're using the manager class, so we're using that builder pattern. And the builder pattern is using, again, all those factories and interfaces to make things work. So everything works tightly together, which makes them the perfect dish together and made by you as a chef. So we're all chefs now. You can now build things. Design pattern fever. So there are two kinds of fever. There's the one where you always want to use and apply design patterns. I hope you don't get that one from this talk. Like I said, there's no silver bullet in doing this. Each situation is different. The second design pattern fever, I hope you do get today, is the fever where you start to recognize all these design patterns. If you look through code bases like Laravel, Symfony, you start to recognize these design patterns. For example, Marcel made the Bouwmann framework, where you can use a different bot like Telegram, Messenger, and so on. He's using almost all these patterns in his framework. If you go through the code, you can actually recognize the patterns. So I hope you start doing that as well. So if you want to learn more, go to one of these links. I will put my slides online as well on SlideShare. Go there. The link is going to a Github repository where a lot of design patterns are explained. Thank you all for listening. Please give some feedback on joining, like Chris already said. And don't forget the other speaker too, Chris as well. I hope to see you next time, and maybe on Friday on PHP Benelux. Any questions? Possible questions? You want to clap or want to do questions?
Yeah, we're going to clap.
So are there questions? So, if you don't know how to get started with this, I started by just reading design patterns, how do design patterns work, and just starting to recognize them in code. And just by seeing how, for example, a strategy pattern is used in 5 projects, you can already see how the pattern works in real life. And like I said, where do you find more of these design patterns? Just in frameworks, in tools, in other languages. You can find them everywhere. So if you want to learn more,